Moin and hello, I'm Lothar from Maygames, and today we will talk about using Epic Online Services with Unreal Engine blueprints. Recently, I've read a lot of requests concerning the Epic Online Services, like, what are Epic Online Services? How can I integrate them with Unreal Engine? And can I use them to run dedicated servers for my game? Spoilers, nope, you cannot run dedicated servers on Epic Online Services. But you can use them for a lot of other interesting things. To show you what can be done with Epic Online Services, we will create this sample game together step by step using blueprints only. We will use the new online subsystem EOS plugin by Epic Games and a modified version of the non-commercial Advanced Sessions plugin. This video was created using Unreal Engine 4.27.2. The online subsystem EOS is currently a beta release, and that's not just empty talk, as we will see. Some parts are pretty broken. Now let's take a quick look at the Epic Online Services. Feel free to skip this section if you already know about EOS. Let's say we've published a single-player game named Rocket. It has some progression system, and players can unlock attachments for the rocket, like a small rocket on top of the large rocket. This is a single-player game, so experience level and unlocked attachments can be stored locally, for example in a save game. This save game may be synchronized to the cloud, but apart from that, it's all handled on the PC where the game is running. So it is absolutely not a problem if there are many people playing at the same time. And if some players exchange their save games, it's fine, who cares? Now, let's say a lot of players have requested a multiplayer mode for the game, and we have finally published an early access version of Rocket 2: The Return. Players can join online games to compete firing their rockets. To save time, we've reused the save game system which we made for the first Rocket game. But of course, people start to copy and modify save games to cheat in online games. And other people complain that people are cheating. In general, we can no longer trust local save games when it comes to multiplayer. There are a few exceptions, like traditional shooter games without a progression system, for example Unreal Tournament. But usually we need to store and update player progression and unlocked attachments in some kind of online service. These online services are the back-end stuff that no one in a game company wants to develop, because it's not really game development. And these services usually do very simple stuff, like storing a certain state. It's pretty common to say, it's easy. Let just Bob do it. Whatever. Sorry to all the Bobs out there. Let just Bob do it. Well, Bob is maybe a UI engineer and probably worked on some big titles like Battlefield 2042. For his great work on Battlefield, Bob is promoted and now he is a full-stack engineer and he will create these simple backends. What could possibly go wrong? Remember error 37? Online services are a very frequent source of player frustration in multiplayer games. I'm very sure you know several examples like these. The problem is, backend services need to scale well and be extremely stable. Bob, in his job as UI engineer, is used to implementing tons of features in a very short time. And of course, there will be glitches. That's normal nowadays in game development. Because of time constraints, large game companies often do not prioritize those glitches. so Bob is used to working that way. But for backend engineering, we need a different mindset. The online services need to work 100% of the time, because if they are not working, not secure, or not scaling up properly, people simply cannot play online. So don't just let Bob do it. Use existing services if possible. In this picture, I've split common game services into two categories. The green category on the left contains general-purpose services like login, matchmaking, player progression, and store items. Some of these services are actually provided by different online platforms. We should not reinvent these services unless we really have enough time and commitment to do so. On the right side, there are services, including dedicated servers and loot boxes, that we usually implement on our own because they are very game-specific. If we are developing the Rocket 2 multiplayer mode for PC or Mac, the most obvious solution will be to use the Steam SDK and Steam services. Steam provides login, matchmaking, and some kind of progression system which may be sufficient. And the services are pretty well tested with Unreal Engine. So instead of telling Bob to write the services, we could simply use Steam. However, if we are also publishing Rocket 2 on consoles or even mobile devices, then that's not easy with Steam. If we want to use the same progression state on our iPad as on our PC, the iPad would need to request the state from Steam. But usually, Steam is not used on the iPad, so it is not working out of the box. Bob would need to implement this. And this is the point where the Epic Online services come in and shine. EOS can be used on all kinds of devices with crossplay. This means with EOS, we can have players using PlayStation, Xbox, PC, iPad, all connect to the same dedicated servers and play Rocket 2. And Bob has more time for his great UI work. In addition to that, Epic Online services provide more functions than Steam, like for example storage and more access write options. This allows us to implement cheat-resistant online save games for Rocket 2 by just using EOS, without implementing a single backend service. To sum things up, what are Epic Online services? EOS are not running our game logic. They are a set of general-purpose gaming services like authentication, matchmaking, and player progression that are provided for free and that can easily be used for cross-platform games. They also provide storage. That's really a huge thing and it's great. I'm really convinced that it is a great idea to give EOS a try. So now we are diving into using EOS with Unreal Engine blueprints. The easiest way to use Epic Online services with Unreal Engine is the online subsystem. An online subsystem, or OSS for Unreal Engine, implements a set of interfaces that can be used to access different online platforms using the same function calls. I'm quite sure some of you already know the online subsystem Steam for Unreal Engine. There are several tutorials available how to use it with blueprints. In general, the OSS Epic Online services implements the same interfaces as the OSS Steam. So the lead engineer of Rocket 2 may think, they implement the same interfaces, we could just switch from OSS Steam to OSS EOS without changing any code or blueprints. In other news, no fat yogurt tastes good. Well, as you probably imagine, it's not working out. We cannot just change the configuration from OSS Steam to OSS EOS and be done with it. At least not for any non-trivial game. It seems that in the current beta release, Epic Games did not design the OSS EOS to be compatible with the OSS Steam. The most recent update improved things a little bit, however, it is still a long way to go. So if you have an Unreal Engine multiplayer game that runs perfectly fine with OSS Steam, do not expect it to work out of the box with OSS EOS. Additional changes will be required. That being said, to demonstrate the usage of the online subsystem EOS, we are starting with a new game from the scratch. After all the theoretical work, we are finally starting Unreal Engine. Let's create a new project in the category Games. As template for our Epic Online Services test game, we choose the third-person template. It has basic multiplayer support. This is a blueprint-only project, no C++ involved. The other settings are pretty much irrelevant. Choose any project name you like. I'll call the project EOS Blueprints. We create the project and the editor is started. It's always a great feeling to start something new. This is the third-person template. Let's just run it for a moment. It comes with a small map where we can run around and jump. And there's another spawn point for a second player who can join, and guess what? The other player can also run around and jump. And this is our goal for today, to let a second player join using Epic Online Services with blueprints only. As a first step, we need a modified version of the Advanced Sessions plugin. We need the blueprint nodes provided by this plugin. The official version of the plugin currently does not work with EOS, but hopefully it will at a later time. So we close Unreal Engine and download the plugin. There's a link below this video. Next, we go to the project folder of our third-person project. I've prepared this here. We create a new folder named Plugins. Plugins. And there we unzip the plugin we just downloaded to this Plugins folder. And make sure it's there. Okay. And I'm also creating a shortcut to the project on the desktop so that it can easily be opened. Fine. Back to Unreal Engine. And we need to make sure that the Advanced Sessions plugin is listed. It should already be enabled because it was placed in the plugins folder of the project. But we are going to verify. Go to Edit Plugins, search for the Advanced Sessions plugin. And there you go, it's already enabled. In addition to that, we need the Online Subsystem EOS plugin. So let's find it, EOS, and enable it. As I already mentioned, it's still a beta release. We're restarting the editor. The other EOS plugins will automatically be enabled with this Online Subsystem plugin. There you go. So now we are ready to go. I have to admit, I'm a little bit impatient. And I remember setting up the Online Subsystem Steam some time ago. I had to do similar steps and then just add some entries to the default engine config file, and basically it was done. So I'm going to rush forward. You don't need to do this yet, it's just a demo. Let's go to the Online Subsystem EOS help, scroll down, and copy the config file entries listed there, like for the Online Subsystem Steam. Go to the config subfolder and paste them to the default engine config file. and then reopen the project and let's see what happens. And bam! I'm being smashed by this crash dialog. This is really a brutal retaliation for a little bit of impatience, don't you think? And it also feels very encouraging. Well, okay, so I got it. I'm undoing all these changes, and I'm going to slow down a little bit. Before enabling the online subsystem EOS in the default engine config, we need to configure the EOS plugin. So open the project settings, scroll all the way down to the plugin section, select Online Subsystem EOS, and we need to set up some parameters here. Most of these parameters come from the Epic Games developer portal, where you need to set up a product. The default artifact name is the name of the product which you set up there. So we enter the default name myProduct. We enable overlay and social overlay so that we see some EOS notifications. Our game is not being launched in the Epic Games Store, but we need to enable Epic Account Services, which is basically the login function. Next, we need to add an artifact, which is, again, the product from the Epic Games developer portal. And again, we are using the default product name myProduct. The encryption key is for simple encryption of some data stored on EOS. We need to enter 64 hexadecimal characters. I'm entering 64 zeros. The remaining parameters need to be copied from the product page on the Epic Games developer portal. Creating a product there is very intuitive. But you need to create a client and assign a client policy. Make sure that the client policy type is set to peer-to-peer. This is very important, otherwise creating sessions will fail at a later time. After creating the product, go to the product page and you will find all the parameters in the product settings. Section SDK credentials. Double check to copy the correct values. The order is different on this page than on the settings dialog. This is not a time to be lazy. And product ID and application ID are two different things. These values should be treated as secrets. This is why I'm not showing them here. Okay, let's just assume that we've entered all the parameters. And now we can finally edit the default engine config as we already tried earlier. We are shutting down Unreal Engine for this. Go to the subdirectory config of the project, open the default engine INI file, and we need to activate the online subsystem EOS here and set it as default online subsystem. There's an official documentation page available for this, link is below this video. And scroll down this documentation page and copy the lines which need to be added to the default engine INI. Paste them into the config file and remove the spaces. Now, as we see, the online subsystem EOS is enabled and set as default platform service, which is what we want. This time, I'm not being smashed by a crash, and the online subsystem is finally enabled. Driven by this small success, I'm getting carried away again. Maybe this time it is as simple as the online subsystem Steam, where we can start a standalone game with Steam running and it will log in automatically, and everything is ready to be used. So the Epic Games Launcher is running, let's start a standalone game. And then we are waiting for the EOS overlay to appear. And we are waiting. And we are still waiting. And we played through the Baldur's Gate series in the meantime, and we are still waiting. To cut it short, there is no auto login by default. at least not for products outside of the Epic Games Store. Bad news. We need to log in manually. In order to do this, we will create a main menu level with a main menu to separate this from the game level. Okay, so we create an empty map. Go to the Maps folder, right-click, New Level, Main Menu, and we open the new map. And of course we build the map so that all the lighting on the empty map is calculated. And we want to set the main menu map as default map. So we go to Edit, Project Settings, Maps and Modes, and we select the main menu map as Editor Startup Map and Game Default Map. Okay, now what we intend to do next is to initiate the login through the main menu. And as a first test, we want to start the login directly after loading the main menu map. To do this, we create a game mode specifically for the main menu. New Blueprint class with parent class Game Mode Base. And we call the new class Main Menu Game Mode. We open it. And next, we implement the Begin Play event for this game mode. We want to log into EOS. There are two login blueprint nodes available. However, the Show External Login UI node is not implemented by the online subsystem EOS. So we have no choice but to use the Login User blueprint node. This node is from the Advanced Sessions plugin. I've modified this node in the plugin and added a parameter called authType. This parameter usually needs to be provided for the online subsystem EOS. The authType tells the online subsystem which kind of authentication we are willing to use. We are authenticating a certain player, so we pass the first player controller. We are not supporting local multiplayer at this time. And we use the authType account portal, which is available by default. This is some kind of interactive login using the web browser. On success, we print a success message. On failure, we print an error message. Compile and save. Now we shouldn't forget to assign this game mode to the main menu map. In the map view, click on Blueprints, World Override Game Mode, and choose the main menu game mode. Okay, now the main menu map is using the main menu game mode, which will trigger the Begin Play node, which will then trigger the Login User node. Maybe we are finally logging into the Epic Online services. Let's try it using a standalone game. Finally, the web browser opens with some confirmation screen. You may have to log in first. We simply confirm both screens, make sure to find the correct button, the colors are inconsistent. And then we see our black map and nothing happens. Just kidding. The login was successful and we are finally getting our social overlay, and we can also press Shift F3 to open the social panel. Note that this is on Windows. There's no such overlay on macOS at this time. That's probably because Epic Games and Apple have so much love for each other. Apart from that, this is a success. We are finally able to log in, and we are clearly on our way to start a server and join a game. Now we need to create a session, which basically means creating a server game, and then join this session which basically means joining a server game. So the next step will be to design a simple menu which allows us to create or join a session. Let's create a UI folder and create a new widget blueprint WBP main menu. We open this widget and we add a vertical box for some buttons. We position the box in the center by setting the anchors, position to 0, alignment to 0.5, and we enable size to content so that the buttons fill the vertical box. Next, we add the first button. I'm setting the button color to something a bit more interesting. You're under no obligation to do this. And next, we add some text to the button. And set some padding so that it looks better. And set the text to create session. And set the button name to button create session. We've prepared the first button and we duplicate this twice for a total of 3 buttons. The second button is the join session button, so we change it accordingly. And the third button is a quit button to quit the game. Okay, we have a menu with 3 buttons: create session, join session, and quit. Next, they should do something. Let's start by implementing the quit button. This is the easiest one. Select the button, scroll all the way down to the event handlers, and implement the onClicked event. There, we simply call the quit game blueprint node. And that's it. We are done with this button. Okay, the main menu is ready for an initial test. We just need to create the widget and display it. The simplest way to do this for our small project is to go to the main menu game mode and create the menu there. So let's just remove the login user call that we added earlier. This will be moved to the main menu widget blueprint later. We call create widget select the widget blueprint main menu and use the first player controller as the owning player. The widget we just created is added to the viewport so that it is shown. Next, we set the input mode to UI only, because we have an empty map and nothing is going on there. So the only interaction will be with the UI. And we pass the button create session as the default widget to focus. And we pass the player controller. And next we enable the mouse cursor for the menu. Okay, test early, test often, we are ready to test the menu. Start a standalone game. The menu is shown, this is all fine. And the quit button is also doing what should be done. Okay, now the serious part begins. The next steps are to implement the create session and join session button handlers. This is somewhat more complex, but we are up to it. Let's implement the create session button handler first, so that later we actually have a session to join. Select the create session button and scroll all the way down to add the onClicked handler. Okay. Since this is a button which can be clicked multiple times, but we only want to log in once, at first we check whether we are already logged in. And we only call login user if we are not yet logged in. And there's a Blueprint node for this. It's called isLoggedIn. And we need to provide the owning player for this. Okay, and only if this player is not logged in, we call login user. For this very player. Again with the auth type account portal. Okay. And on failure, we print an error message. And on success, we finally create a session. This basically means we prepare a server. We use the node create advanced session for this. It is provided by the Advanced Sessions plugin. There are a lot of parameters available. We provide the owning player and set the number of public connections to 8, because this is not Fortnite. And also, we disable lobbies. Lobbies with the online subsystem did not work at all in 4.27.1. In 4.27.2 it kind of works, but there are still some problems, so for now we are not using them. On failure, again, we run around panicking and print an error message. And on success, we print a success message and continue from there. As next steps, we need to remove the main menu and start the game map in listen mode. So we call remove from parent to remove the menu widget. And next, we set the input mode to game only, because there will be no more UI. And then we disable the mouse cursor again. And now we are opening the default game level using the node open level by name. The exact level name can be found in the maps subfolder. It's called third person example map. and we provide this name. And we use the option listen to start a listen server. This is very important. And that's it. We have just implemented a game server using Epic Online Services with blueprints. Let's test the server in a standalone game. Click the Create Session button and confirm the login 2 times. Have some patience. And then our listen server is running. If this fails, make sure you have set up your product on the Epic Games Developer Portal in a way that the client policy allows you to create sessions, which is, for example, client policy type peer-to-peer. We should not click the Login button again while creating the session is still in progress. So in a new development iteration, the code should be protected using a gate blueprint node or something similar. But for the sake of simplicity, we are not doing this right now. However, we will do some refactoring. When implementing the Join Session button, we also need some of the current functionality. For example, we need to log in. And of course, we try to avoid too much copy and paste. We cannot collapse the login code to a function because a latent blueprint node is used. That's the one with the clock symbol. So we are collapsing the code to a macro. There is a special trick to avoid too many output nodes. Just create a reroute node to combine outputs. And afterwards, collapse to a macro. We call the macro login. And we adjust the node a little bit and open the macro. We clean up a bit and then we fix the output pins because the order is bad and the first output pin should be called onSuccess. Note that we are not using the first output pin of login user, because we are assuming that the login either fails or is successful, which implies we are hoping that this is implemented correctly. Well, I will comment on that later. Naturally, we want things to look nice and in order, so we move the nodes a bit. This over there. And this node up a bit. Okay, fine. Next, there are these calls to remove the main menu. We also need them when joining a session. And we do not want copy and paste, so we collapse these nodes. This time there is no latent node, which is why we prefer a function. For this function, we use the name clearUI. And again, we adjust the nodes a bit. And just in case, we check the function, but it's fine. Okay. To sum things up, we log into EOS, create a session, and then we remove the main menu and open the game map in listen mode. With this small refactoring, we are now well prepared to implement the Join Session button. So let's select the Join Session button widget and add the onClicked handler as usual. Okay, now our earlier work pays off, and we can simply use the login macro to log in. It's right at the bottom. Okay, On failure, we print an error message. On success, we are trying to find a session that was created by another player using the Find Sessions Advanced Blueprint node. This node also has a lot of parameters. First, we pass the owning player of this widget blueprint. Okay, and we intend to simply join the first session, which means we only need a single result. Now watch out, this is different from Steam. We need to select dedicated servers only as server type, even though we are not trying to find dedicated servers. This is because the session filters of EOS are not compatible to the filters used with Steam. Okay, and since we disabled lobbies when creating the session, we are also not searching for lobbies, so we disable this parameter. And on failure, again, we print an error. And success means that we successfully search for a session, but we might still not have found any. Therefore, the next thing to do is to check the length of the array returned by find sessions. If the length is greater than 0, we actually found a session. If it is not greater than 0, we print an error message that no session was found. If we actually find a session, we join this session using the Join Session node. This is actually a built-in Blueprint node which works without a plugin. The owning player should join the session. And now we need to get the first session result, which is the session we found and we wish to join. There's no room for this get node, so we move the nodes a little bit. There you go, now it's fine. Joining a session can again be successful or not. So we print a message on success. And of course, we are not forgetting to also print a message on failure. On success, we also call clear UI, which is the function we created earlier to remove the main menu. When joining a session, we do not need to open a map. The client will automatically travel to the server map, and this means we are done after clearing the UI. Okay, it's time to sum things up. At first, we log into EOS. Then we look for a session using the server type dedicated servers, and we do not search for lobbies. And we check whether we found a session, and if so, we join the session, and then we remove the main menu. That's it. Next, we should test creating and joining a session. But that's not so easily done. We need to run 2 instances of the game with 2 different Epic Games accounts, because otherwise joining the map will fail. I'm afraid that you do need to create a second account for this. And I'd also recommend to use a second system, for example, use a laptop or another PC. If you did not perform a brand review for your product yet, you also need to add the second account to your product development team. Otherwise, the second account will not be able to log in using the game. Go to the Epic Games Developer Portal, click on Organization, and invite the second account to your development team. You should at least choose the role Epic Account Services and either choose all products or this specific product and invite the member. Okay, now let's just assume that we have created a second account and started a session on another PC. Now we can finally run a standalone game and join the session. I can't wait to see it. Click on Join Session and confirm the login again and again. And be patient. And that's it! Session success! We have joined a networked game using Epic Online Services. The server player is standing over there. He can run and jump, and all the replication mechanisms of Unreal Engine are now working. We are in a multiplayer game. Epic Online Services does not host this server, but it did the session handling for us. The server was registered online and it was found using the Find Sessions Advanced Blueprint node. This Find Session function is part of the matchmaking service of Epic Online Services. Okay, basically we are done. This is the simple example that I wanted to develop with you to demonstrate using Epic Online Services with Unreal Engine blueprints. One thing that is still kind of bad in the current implementation is that you need to manually confirm the login twice each time you log into Epic Online Services. This is really bad, as it will eat up a lot of time during development. And also, of course, we cannot ship a game like this. Epic Games is offering a brand review process for you to get rid of these confirmation screens. And also for not requiring all players to be invited to the development team. Apart from that, there are other options. In general, Epic Online Services support a persistent login, where a token from a previous login is still stored and can be reused. One might assume that maybe the online subsystem also supports auth type persistent. A possible process would be to try a non-interactive persistent login and only switch to account portal login if this fails. The process would look like this. Attention, this is only a theory. I'm not saying that it works. We could use two login user nodes. On failure of the persistent login node, we run account portal login. This would not require a brand review and could still be used for development. But unfortunately, there are two serious problems with this. The first problem is that the auth type persistent is supported by Epic Online Services, but it's not supported by the online subsystem EOS. This one could easily be patched in the engine source code. But the second problem is that the onFailure node is not firing correctly. In other words, the onFailure node is not working at all in the current beta release of the online subsystem EOS. This is not a problem of the Advanced Sessions plugin, it's a bug in the online subsystem. If login fails, Epic Online Services will call the failure handler, but the online subsystem does not forward this to the onFailure node. This creates the impression that, in its current state, the online subsystem EOS was mainly designed for use with the Epic Games Store. The failure node is not easily fixed, so using the persistent login sadly is not an option for now. We can undo all this. What we can do instead is use other values for the auth type. Auth type exchange code is for use with the Epic Games Store. I'm not going to talk about this. Auth type developer is used with the DevAuth tool provided with the EOS SDK. This is the recommended way by Epic Games, but I think for indie developers it is a very bad idea. The Auth tool is not a service to be used in production, which means we are basically testing our game with a non-production helper tool. This would be fine for automated tests, for which we don't have the infrastructure. But when testing our game, it should be as near to the production release as possible to find bugs early on. Also, the tool is trying to solve a problem that should not be there in the first place. In my opinion, basically everything is better than this DevAuth tool. The last option for auth type that is currently supported is empty, or platform-specific value. Empty is for use with EOS Plus, which can basically use a Steam login to log into EOS, which is a lot more comfortable. The online subsystem EOS Plus helps us to support crossplay and allows us to use non-Epic Games login methods. This may be the way to go. If you enjoyed this video and would like to see more, please leave some feedback. Maybe I will create another video about using EOS Plus. Have a wonderful time!